Logic Lesson 10, Biconditionals. In this rule, we're going to learn how to symbolize biconditional statements, and we're going to learn two new rules, the double arrow in rule and the double arrow out rule. A little bit of review first. To prove that an argument is valid, identify the final conclusion and basic premises, symbolize each statement in the argument, construct a proof table to demonstrate that you can get from the basic premises to the final conclusion using a series of valid inferences. Proof tables. Remember that an argument is valid if and only if each inference from basic premises to final conclusion is valid. Proof tables demonstrate how to move step by step from basic premises to final conclusions using only valid inferences. Each line of the proof table must cite a valid inference rule, which will guarantee that each inference is valid and that the whole argument is valid. You have learned arrow out rule, which states from two premises, one of which is a conditional, and the other is a statement or formula that exactly matches the antecedent of the conditional, you may infer the consequent of the conditional. Remember, whenever you use arrow out rule, you must cite two lines, a conditional statement and a statement matching the antecedent of the conditional. And in rule, infer the conjunction of any two statements. That easy. From G and C, infer G and C. And out rule, from a conjunction, infer either conjunct. To apply and out rule, you must have a conjunction. You may infer the conjunct on the left, or you can infer the conjunct on the right. The last rule that you learned is arrow in rule. Arrow in rule states, well, first of all, use this rule only when your conclusion or your sub-goal is a conditional statement. This is only for getting a conditional statement. The rule states, provisionally assume the antecedent of the conditional you're trying to prove, derive the consequent of the conditional you're trying to prove, and then infer the conditional. Remember, the arrow in rule is an elimination dependence rule. It eliminates your dependence on the provisional assumption as long as the provisional assumption exactly matches the antecedent of the conditional that you infer using arrow in rule. Let me say that again. Arrow in rule is a dependence elimination rule. It eliminates your dependence on the provisional assumption, which matches the antecedent of the conditional you infer. Once you've eliminated dependence on that provisional assumption, do not use that provisional assumption again. I'll talk about this more later in the lesson. Alright, let's move on to the new content, the new material, biconditionals. Biconditional is another logical form that statements can take. We're going to symbolize biconditionals with this double arrow symbol. Biconditionals are statements where two smaller statements are connected with the logic words if and only if, or with synonyms for if and only if. Biconditionals are statements where two smaller statements are connected with the logic words if and only if, or synonyms for if and only if. Here are some important synonyms, but not the only synonyms for if and only if. Just in case. In case would be a synonym for if, or if then, but just in case means if and only if. exactly if, necessary and sufficient. So we remember that necessary conditions are the consequent of a conditional. Sufficient conditions are the antecedent of a conditional. So something that is a necessary and sufficient condition for something else, those are linked both ways. They're biconditional. IFF is an abbreviation that you will often see in logic and math for if and only if. There are others. Can you think of other synonyms for if and only if? You may find some in your reading assignments. Okay, so biconditionals have two rules, an introduction rule, an in rule, and an out rule, just like the other logical operators that we've learned. So double arrow out rule states, from a biconditional statement or formula, infer either of the corresponding conditionals. Let me explain with an example. If we have the biconditional A, double arrow B, A, if and only if B, we can infer A, arrow B, if A, then B. And we cite line 1 and the double arrow out rule. We could also infer the other corresponding conditional, B, arrow A, again citing line 1, double arrow out rule. So notice that these conditionals on lines 2 and 3 are the corresponding conditionals to the biconditional on line 1 because they have the antecedents and consequents of the conditionals on lines 2 and 3 match the formulas that the biconditional joins on line 1. Let's do one more example just to make sure that we have a clear idea. Here's a biconditional statement, U and A, if and only if N, then B. We can infer either of the corresponding conditional statements using the double arrow out rule. If U and A, then if N, then B, citing line 1, double arrow out rule. Or if N, then B, then U and A. Again, line 1, double arrow out rule. As long as each antecedent and consequent matches the various parts of the biconditional, you can infer either conditional. From a biconditional statement or formula, infer either of the corresponding conditionals. Double arrow out rule. Let's move on to double arrow in rule. It's a little bit more complicated, but not much. From any two conditionals where the antecedent of one of the conditionals matches the consequent of the second conditional, and the antecedent of the other conditional matches the consequent of the first conditional, infer one of the corresponding biconditionals. Again, this is going to make a lot more sense with an example. Suppose we have the two conditionals, if A then B and if B then A. Since the antecedent of the first conditional, A, matches the consequent of the second conditional, A, and the antecedent of the second conditional, B, matches the consequent of the first conditional, B, right? Since they match here and here, we can infer A if and only if B. When we use the double arrow in rule, we need to cite two lines. Each of those lines must be a conditional, and then we cite the double arrow in rule. Let's have one more example. Oh, before we get to the other example, we could have also inferred this biconditional, B, double arrow A. Another example. Conditional on line 1, if U and A, then N and B. Conditional on line 2, if N and B, then U and A. So we have two conditional statements. The antecedent of the first conditional matches the consequent of the second, the antecedent of the second conditional matches the consequent of the first. And since we have two conditionals with matching antecedents and consequence, we can infer the biconditional. U and A, double arrow, N and B. Again, we cite two lines, line 1 and line 2, since they contain the corresponding conditionals. We could also have inferred instead if N and B, double arrow, U and A. Again, citing lines 2 and 1. And double arrow N. Okay, so those are our two new rules from any double arrow N from any two conditionals where the antecedent of the first matches the consequent of the second, and the antecedent of the second matches the consequent of the first. Infer one of the corresponding biconditionals, so double arrow in rule and double arrow out rule. The last thing I want to talk about is combining double arrow in rule with arrow in rule. We can call this biconditional in plus arrow in strategy. We can use this strategy when our conclusion or subgoal is a biconditional statement and you see no other easier way of deriving that conclusion or subgoal. So biconditional in plus arrow in strategy works like this. You have your biconditional as your goal or your subgoal, so you're going to set each of the corresponding conditionals as subgoals. And then work on each conditional one at a time. Provisionally assume the antecedent of the first conditional. Set the consequent of the first conditional as a subgoal. Derive that consequent. Apply the arrow in rule to infer the first conditional. Now you've got the first conditional. Move on to your second conditional subgoal. Provisionally assume the antecedent of that conditional. Set the consequent of that conditional as a subgoal. Derive the consequent. And apply the arrow in rule to infer that second conditional. Then, using those two conditionals, apply the double arrow in rule to infer the biconditional. So let me give you an example of how that works. So I'm going to prove this argument. H, if and only if I and J, therefore H, if and only if I. Okay, sorry, this should say H, if and only if I and J, J, therefore H, if and only if I. So I've got my basic premises listed here, and now I notice that my conclusion is a biconditional, so I'm going to set for myself two subgoals. H arrow I and H and I arrow H. If I can get both of these conditionals, I can use the double arrow in rule to derive this biconditional. So I'm going to set these two conditionals as my subgoal, and then I'm going to go for them one at a time. So I'm going to work on this conditional first. So for line 3, I'm going to provisionally assume the antecedent of this conditional, and I'm going to set I as my subgoal. Now that I have a provisional assumption, I'm going to start my dependence column. Okay. So what am I going to do? Well, I have a biconditional on line 1, so I might as well use the double arrow out rule. And I can get H, arrow, I, and J from line 1 and double arrow out rule. So I only have to say one line when I use the double arrow out rule, the line with the biconditional. This is going to depend on line 1. Okay, and now for line 5, I see that I have this conditional here, and on line 3 I have the antecedent of the conditional, so I can infer the consequent, I and j. That's from lines 4, 3, arrow out. Now I need to do my dependence column. I used line 4 and line 3, so I need to see what they depend on. Line 4 depends on 1, line 3 depends on itself, so I'm going to put 1 and 3 in the dependence column. Okay, next. I have I here as my subgoal, so I can get I from this conjunction on line 5. So on line 6, I'm going to do I from line 5 and out rule. So I used line 5, so I need to look at what line 5 depends on. Line 5 depends on 1 and 3, so line 6 depends on 1 and 3. Okay, now I have this subgoal, right? I've got this subgoal, so that means that I can now use arrow in rule. So H, arrow, I, and that was from my provisional assumption on line 3, and the whole line of reasoning that got me to line 6, 3 through 6, arrow in. Now lines 3 through 6 depended on lines 1 and 3, but line 3 is the provisional assumption that matches the antecedent of this conditional, and since arrow in rule eliminates dependence on the provisional assumption that matches the antecedent, I only depend here on line 3. Now, I'm not done. I have the first subgoal here. I need to now get this subgoal, but I must make sure once I've eliminated dependence on the provisional assumption on line 3 that I don't reintroduce dependence on that, which means I cannot use line 3 and I can't use any line that depends on line 3. So I can't use line 5 or line 6 either. So anything from line 5, 6, or 3 is out of commission. I cannot use those lines. Okay, now that I have my first conditional, I'm going for the second conditional in my subgoal here, and so on line 8, I'm going to provisionally assume the antecedent, and I'm going to try to derive the consequent, so I'm going to set H as my subgoal there. And since line 8 is a provisional assumption, it depends on itself. Okay, so now I'm trying to get H. Well, what can I do? What am I going to do here? The only place that I see H on a line that I could possibly use is line 1. So I'm going to use the double arrow out rule. This time I'm going to get this conditional. I and J, arrow H, and that is from line 1, and double arrow out, right? So I can get this conditional from using the double arrow out rule. This is going to depend only on line 1 since I used line 1. Okay, now what do I do? I'm trying to get H. I have I here on 9, and I have J here on line 2, so I can get I and J. That from line 8 and line 2 and in. So line 10 is going to depend on line 2, because line 2 depends on line 2, and it's going to depend on line 8, because line 8 depends on line 8. So I will put lines 2 and 8 here. Okay, that's nice, because now I have the antecedent of this conditional, which allows me to infer the consequent h, and that is from 9, 10, arrow out rule. I used lines 9 and 10, so 11 is going to depend on what lines 9 and 10 depend on. Line 9 depends on line 1. Line 10 depends on line 2 and 8. So line 11 depends on 1, 2, and 8. Okay, now I have h, which was the sub-goal here with my provisional assumption. And so now I can use arrow in rule to get I arrow h. That's from line 8, where my provisional assumption is, through 11, where my consequent is, and that's the arrow in rule. So arrow in rule, my provisional assumption is the antecedent of my conditional, making that provisional assumption led to the consequent of my conditional, so I can infer the whole conditional. Okay, so what does line 12 depend on? Well, I used lines 8 through 11, and on lines 8 through 11 I have 8, 1, and 2, but since line 8 is my provisional assumption, and now I'm only saying if that provisional assumption were true, then h would be true. I no longer depend on my provisional assumption, so I only depend on lines 1 and line 2. Okay. Well, so now I have this second conditional subgoal, so now I have both the conditionals that I need to use biconditional or double arrow in rule to get my conclusion. So on line 13, I can now get my conclusion. H double arrow I, and this is from line 7 and line 12, double arrow in, right? Because line 7 contains one of the corresponding conditionals and line 12 contains the other corresponding conditional. I can infer the biconditional. So line 13 is going to depend on what lines 7 and 12 depend on. Line 7 depends on 1. Line 12 depends on 1 and 2. So line 13 depends on 1 and 2. 1 and 2 are our basic premises, so we're in good shape. Line 13 does not depend on either provisional assumption, and so our argument is valid. So let me just recap the strategy here. I had a biconditional as my conclusion. So I set each of the corresponding conditionals as a subgoal. Then I worked for each subgoal one at a time. So I worked for this conditional first, provisionally assuming the antecedent on line 3, deriving the consequent on line 6, and then inferring that conditional on line 7, which eliminated dependence on my provisional assumption. Now that I had this conditional, I moved on to try to get my second conditional, being careful not to reintroduce dependence on my first provisional assumption. So again, this time I provisionally assumed I, since it was the antecedent of my conditional. I set H as my subgoal. On line 11, I derived H. So on line 12, I inferred the conditional if I, then H. This eliminated dependence on the provisional assumption I. And then on line 13, I applied the double arrow in rule to get my conclusion. Okay, so that was it. Biconditional in plus double arrow in strategy. And again, just a caution, the arrow in rule eliminates dependence on the provisional assumption, which is the antecedent of the conditional you infer using arrow in rule. So be sure that once you have eliminated dependence on that provisional assumption, you do not reintroduce dependence. Do not use that provisional assumption again, and do not use any line that depends on that provisional assumption. That's really the whole point of that dependence column, is to make sure that you don't reintroduce dependence on a provisional assumption once you've eliminated dependence on it. If you do reuse the provisional assumption or any line that depends on that provisional assumption, and you reintroduce dependence on that provisional assumption, your proof is not going to be valid. You're not going to have proved your argument valid. Okay, so that's it. That's the lesson for today. Make sure that you can identify synonyms for if and only if, symbolize biconditional statements using the double arrow symbol. Make sure you understand the double arrow out rule. From any biconditional, you may infer either of the corresponding conditionals. Make sure you can use the double arrow in rule from two conditionals where the antecedent of the first matches the consequent of the second, and the antecedent of the second matches the consequent of the first. You might infer either biconditional. You should know how to use the double arrow in strategy with the arrow in. That was the example proof that I did. I will post that on Blackboard to study if you are confused about it.